Baseball is a sport that incorporates many aspects of physics within it. It involves forces applied, projectile motion, Newton's three laws, and energy and work done by the. It is a competitive sport that is played globally in many various areas around the world. The goal of the sport is to score points by striking a thrown ball and running to a series of four bases, stored in the areas of 90 square feet. Each team takes turns attempting to score points for their team. To start off, there are several different forces in baseball that take effect. The defending team's goal is to strike out the batter or get the batter out. In doing so, the pitcher needs to apply force on the ball. The speed and the velocity of the ball is determined by the pitcher. A pitcher is capable of applying many different types of forces that changes the ball's flight path in different ways. For example, a pitcher can apply force to a ball that causes the ball to sink as it gets closer to the batter, otherwise known as a curveball. This makes the batter think that he can swing at the ball. Pitching directly relates to Newton's first law of motion, which states that every object remains at rest or in uniform motion unless an external force is acted upon it. Pitchers place lateral spin on their throws, understanding that the air pressure acting on the surface of the ball causes it to move several inches sideways as it crosses the plate. Catchers, on the other hand, while on the field, anticipate where the ball will land if it is struck by the batter. The projectile motion of the baseball travels in a parabola due to the acceleration of gravity, the angle in which the ball was hit, and the initial velocity of the ball. Outfielders use physics, knowing that you need to position yourself half the displacement of the maximum height of the baseball. Using projectile motion, we know that this is exactly half of the ball's flight path, and the catchers use this to determine the angle of the ball when it lands in their glove and the amount of time that it will take to reach them. In baseball, the batter's shoulders are very similar to coiled springs loaded with potential energy. As the swing of the batter progresses, more and more of the energy is then converted into kinetic energy. This means that hitting the ball later in the swing results in a faster bat speed during the moment of contact. Newton's second law of motion shows that the velocity of a mass object changes when it is subjected to an external force. This bat speed is an important factor when the batters are hitting for distance. This is mainly about momentum, which is a product of the mass multiplied by the velocity. A 31-ounce bat has over 6 times more momentum than a 5-ounce baseball. This is why swing speed is much more important when compared to pitch speed when hitting the ball. Still, not all of the energy is directly converted from the bat to the ball. Some of the energy still remains in the bat as seen in the follow-through. Another big factor in batting is the angle of contact. As the angle increases, so does the distance. An angle increased as small as 10 degrees can increase the flight path and distance of the baseball as much as 15 feet. Hitters also exploit this phenomenon in certain situations by swinging at a lower velocity to hit between the outfielders and the infielders. Newton's second law can be dramatically illustrated when hitters bunt. Since the mass of the bat is not in motion, the mass acceleration is provided by only the pitched baseball. This results in a bunt that rolls to a stop short of an infielder. Overall, these are the main types of physics behind baseball that each and every player takes into consideration when playing this sport. This now concludes the physics behind baseball by Tyler Mira.